So in this video, let us discuss about the conversion of a decimal into binary. For example, we have a number 25. We want to convert this number into decimal form. So first thing what you have to do is you write just 25. Now divide this 25 with the number 2. Then what will you get? 12.5. Actually 25 by 2 is 12.5. Here, see 12.5 means there is a decimal point in here. Or you can see that the 5 comes after the decimal point. Okay. When there is a decimal point, you just write r equal to 1. The remainder is 1. Okay. If there is no decimal point, that is it is perfect division, you put remainder equal to 0. We'll come to that. Okay. So here the remainder is 1. Now take the integral part only, that is this 12 only. Clear? For the next division. Then you write 12 here, then 12 by 2, which is equal to 6. Here it is a perfect division because there is no decimal point. Then you put remainder equal to 0. Okay. Now a second case, the first case we have remainder equal to 1 since there is a decimal point. On the second case there is no decimal. So you can write remainder equal to 0. Then you proceed like this. Now again you take the 6 here. Then again divide it with 2. 6 by 2 which is equal to 3. Again there is no decimal point. So you can write remainder equal to 0. Now take this 3. Then divide that 3 with 2. Here you will get 1.5. Clearly there is a decimal point. So you can write r equal to 1, remainder equal to 1. Now only take this integral part, that is 1. Then 1 by 2 is equal to 0.5. Again the remainder is 1 since there is a decimal point here. Now if the integral part is 0, then you can stop. Now there is no need to proceed further. Okay, when there is 0, when 0 comes, you can stop here. Now this is the most significant bit and this is the least significant bit. You should always count from most to least. Clear? So it is from bottom to top. So the binary of 25 is actually 1 1 1 0 0 1. Clear? So this is the binary of 25. So in decimal form we write that as 25 to the base 10, which means it is in the decimal form. In binary it is 1 1 0 0 1. Okay. We put the suffix 2 since it is binary. Binary means there is only 0 and 1. Clear? Now let's take another example. Let's take let's say some 172. Okay, you do the same thing. First write 172, then divide 172 with the 2. Here it is a perfect division, so it's the 172 by 2 is 86. So the remainder is 0. Now take this 86, then 86 divided by 2, which is equal to 43. Here also remainder equal to 0. Now take the 43. Now divide 43 divided by 2, which will give 21.5. Here there is a decimal point, so you have to write remainder equal to 1. Now take only the integral part. You should be careful about that. You only need to take the integral part. So 21, again divide it with 2, you will get 10.5. Here also the remainder is 1 since there is a decimal point. Now take this integral part, that is 10, then 10 divided by 2, which is equal to 5. That is a perfect division, so remainder should be 0. Now 5 by 2, that is 2.5, remainder should be 1. Now take the integral part, 2 2 divided by 2, which is equal to 1. The remainder must be 0. Now take 1. 1 divided by 2, which is 0.5, and the remainder is 1. As I said before, when 0 comes on the integral side, you can stop. Now count from the most significant bit to the least significant bit. So it will be 1 0 1 0 1 0 1 1 0 0. So 172, the decimal number can be written like 1 0 1 0 1 1 0 0 in binary. Clear? So let's take one more example. Let's take some 278. Okay, you do the same procedure, that is 278 divided by 2, which is equal to 139, and its remainder is 0 since it is a perfect square. Again take this 139, that is 139 divided by 2, which will give you 69.5 as the answer. So the remainder should be 1 since there is a decimal point. Now take the integral part only, that is 69. Now 69 divided by 2, that is actually 34.5. So the remainder is again 1. Now take the integral part only, 34. 34 divided by 2, which is 17. That is a perfect division and there is no remainder. Now 17 divided by 2, which is equal to 8.5. Here the remainder is 1. Now take the 8 divided by 2, the division is 4, so the remainder is 0. Now 4 by 2, which is equal to 2, the remainder is 0. Now 2 divided by 2, which is equal to 1, the remainder is 0. And finally 1 divided by 2, which is equal to 0.5. Here the remainder is 1. Now you can stop since we reached 0. Now count from bottom to top. So 278 in the decimal form can be represented as binary, as 1 0 0 0 0 0 1 0 1 1 0 to the base 2. Clear? So this is the way how you convert decimal into binary. Now we also need to convert this binary into decimal. Okay. So how will we do that? This time we have to convert the binary into decimal. For example, we have a number. Let's take the example here. Let's take the same example we considered here, that is for the conversion of decimal to binary. We got 11001. This is the expansion of binary for 25. We know that. So how will we convert this binary into decimal? For that, you just write it like this, 1 1 with some space. Now let's consider the number which is at the extreme right hand, which is 1. Above that, you just write 2 raised to 0. Now increase the power of 2 as you move from right to left. That is, here it is 2 raised to 1, 2 raised to square, 2 cube, that is 0 1 2 3, then 2 4. Since there is no binary after here, you can stop it here. Now you know 2 raised to 0 is actually 1. actually any number to the power 0 is 1. Now 2 raised to 1 is actually 2. 2 square is 4. 2 cube is 8. 2 raised to 4 is 16. Now see, so write it like this. Then you have to only take that number which is under the 1, that comes under 1. That is, you can take 16, that is 8, that comes under 1. You can eliminate this 4 and 2 because it comes under 0. Okay, then add these numbers, that's 16, 8 and 1. So 16 plus 8 plus 1. So that is equal to 24 plus 1, 25. Okay, so this is actually 25. Clear? And this is the simplest way you can do that. Now, let's take the other example. We have the binary of 172 as 1 0 1 0 1 1 0 0. We already know this is the expansion of, this is actually the binary of 172. Now we want to confirm that. We want to know how to bring 172 from its binary. Again, as I said before, write these digits with some spaces. 1 1 0 0. On the extreme right end, you just put 2 raised to 0. Then increase the powers. 2 raised to 1, 2 square, 2 cube, 2 raised to 4, 2 raised to 5, 2 raised to 6, now 2 raised to 7. 2 raised to 0 is actually 1, 2 raised to 1 is 2, 2 square is 4, 2 cube is 8. You can also there is no need to write like this. You can put 1 here, then multiply all the terms with 2. That is 1 here, 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8. Then here it will be 8 into 2, 16. Okay, in this way also there is no need to write the powers of 2. Clear? Now here it will be 32, here it will be 64, finally 128, and there is no binary after this. Now as I said before, consider only that is under 1. Okay. And eliminate everything which is under 0. So the answer will be 128. Now add all those that comes under 1. 32 plus 8 plus 4. So that will, if you add, you will get 172. Okay, so this is actually 172. Clear?